So in this case, we've got an octopus is able to catch any fish that swims within a distance of 2 meters from the octopus's position. So it says the octopus is modeled as a fixed particle at the origin O. The fish travels in a straight line from A to B. And it says if that fish swims within 2 meters from the octopus, it can catch it. So we've worked out that this is the shortest distance problem between the octopus and the path of the fish. And if the shortest distance is less than 2 meters, then it can catch it. And if it's bigger than 2 meters, it can't catch it. Okay. So we need the equation of the straight line. So we get the vector A to B. So if we do 9, 4, 11, minus 3, 1, minus 7, I get 12, 3, 18. This is the direction vector of the line. You can use any multiple of that, so you might have got negatives. You can divide it all through by 3 and use 4, 1, 6. That's fine as well. The equation of the line then, so use a point that the fish goes through. So use minus 1, minus 3, 1, minus 7, plus lambda times your direction vector. I'll just stick with using this because I think most of you did use that. So 12, 3, 18. This is the equation of the line that the fish is on. The point x, we don't know where it is on the line. So the point x, the position vector of x is just what I get when I smush this together. So minus 3 plus 12 lambda, 1 plus 3 lambda, and minus 7 plus 18 lambda. Usually, you would have to subtract that generic point from the point that you find in the shortest distance between. But in this case, because we're finding the shortest distance from the origin, this is just the vector O to x. I mean, you'd be taking off 0, 0, 0, x. Wherever that x is for the shortest distance, I know that it's perpendicular to the direction vector of the line. So if I now do the dot product between this and the direction vector of the line, which is 12, 3, 18, this will be equal to 0 because it's perpendicular. Do this dot product and you get an equation in lambda. Yeah. It's not red because I'm using the browser version. It's not working. But it is. So I get minus 1, 2, 6 and 2, 3. And if you solve this, so you get 477 lambda equals 159 minus 159, positive 159. And so I think you get lambda as a third from this one. Depending on what you use for your direction vector, you might get different answers. You might get minus third, you might get 1, you might get minus, but not a 4. Probably not 2 or 3. You could get 2 or 3, depending on what you use. Yeah, depending on what you use. Stick this into OX. So you put in a third into OX, you'll get 1, 2, minus 1. Length of OX then is 1 squared plus 2 squared plus 1 squared square rooted, which is root 6. This is bigger than 2 because 2 squared is 4, so root 6 is bigger than 2. So the octopus cannot catch the fish. And you've got to write a sentence there. It doesn't like it. Then there'll usually be at the end of these questions like evaluate the model or criticize the model or something. So criticize the model in relation to the fish. Just say something like, well, the fish is not going to swim exactly in a straight line. Sorry.
Fish might be very fat.
Yes.
Like this little fish.
Yeah. Because we've modeled it as a particle, but it might be a big fish, so it might be enormous. So criticize the model in relation to the octopus. The octopus is again not going to stay fixed.
Its arms don't start at the origin because it has the little stiff lip.
That just means that he can reach further.
Yeah, exactly.
You could say there's some reaction time or something that might. As long as it's sensible, you should get. Right, there's another question in context, and again, these are really hard to kind of picture, and quite often it's really hard to draw diagrams for them as well. Sometimes you'll get diagrams, sometimes you won't. It varies. So here we haven't got a diagram. So let's have a read through this. So we've got a gas company maintains a straight pipeline. So I'm immediately thinking, right, this is an equation of a straight line that passes under a mountain. The pipeline, oh, it tells us it's modeled as a straight line, and one side of the mountain is modeled as a plane. So this time we've got a line and a plane. It says there are access ways from a control center to two access points on the pipeline. The control center is the origin, and the two access points have these coordinates, P and Q. Wants us to find the vector equation for the line PQ. So this is quite confusing. Lots of stuff in here, but ultimately pick out the vectors, and it's asking you basically to do a vector equation between P and Q. Okay, for the first bit, which should be fine. So if we do the vector P to Q, this is 300 minus 50. Take away P, so minus 300, 400 minus 150, which gives us 600 minus 100, 100 for our direction vector. I'm going to use 6 minus 1, 1, so that's right out so many zeros. And I can use either point that it goes through, so I'll use P, doesn't matter. Plus lambda times 6 minus 1, 1. Any multiple. Okay. And the next bit, it gives us the equation of the plane. So it gives us in Cartesian form. And it says the company wants to create a new accessway from this side of the mountain to the pipeline. The accessway will consist of a tunnel of shortest possible length. So this is a shortest distance problem between the pipeline and the point 100, K 100 on this side of the mountain, where K is a constant. And it wants us to find the coordinates of the point where this will meet the pipeline and the length of this tunnel. Okay. Ultimately, this one is a shortest distance between a line and a point. Okay, so it's got a plane in there as well, but it's not a shortest distance between a point and a plane. It's between the point and the line. Okay. First thing I'm going to do is figure out what K is. If this point 100K 100 is on the side of the mountain, I can substitute it into the equation of the plane and work out what K is. Okay, so if I get 2 times 100 plus 3 times K minus 5 times 100 plus 300, I can work out K, so that's minus 300. So I get 3K equals 600. K is 200. That's from the equation of the plane. Okay. We're then doing the shortest distance between the point 100, 200, 100, and the line R equals minus 300, 400 minus 150. Plus lambda 6 minus 1. Okay. That's half the battle in these is reading the question and working out what it's actually asking you to do. Again, this is shortest distance between a point and a line, just like we've just done. So my point's here. This is my equation of my line, and this is my foot of the perpendicular. We'll call it X. So just like we did on the previous question, let's give this, I'll call this A as well. Yeah. So X is the foot of the perpendicular. We're going to get from smushing it together. So minus 300 plus 6 lambda, 400 minus lambda, minus 150 plus lambda. The vector A to X I'm going to get from taking these away from each other. I'm going to run out of space. So take away the coordinates of A, which is 100, 200, 100. And so I get minus 400 plus 6 lambda, 200 minus lambda, minus 250 plus lambda. So this is the same as what we did last time, but last time we had O instead of A. This time we've actually got to take them away from each other. I'm going to make a bit more space by moving this out. Hope that's okay. So I need to do AX dotted with the direction vector of the line. So minus 400 plus 6 lambda, 200 minus lambda, minus 250 plus lambda, dotted with the direction vector of the line, which was 6 minus 1. And this is equal to 0 because I know they're perpendicular. So minus 2,400 plus 36 lambda, minus 200 plus lambda, minus 250 plus lambda equals 0, just from multiplying those and adding them up. Collect up your lambda, so I get 38 lambda. Collect up your other values, so minus 2,850. So 2,850. If I do that division. Get lambda 75 seems like a nice number so far. Divide is hard. To get the coordinates of the point at which this tunnel will meet the pipeline, that's asking for the coordinates of x. So I'm going to substitute this lambda back into O to x. So that's minus 300 plus 6 times 75. 400 minus 75 minus 150 plus 75 is 150 325 minus 75. Okay, so that's the answer to part I. It's the coordinates of the point at which the tunnel will be pipeline. The length of this tunnel, I want the vector AX and do the length of that. So I've put in 75 into there. I'll get 50, 125 minus 175, and if I do the magnitude of that, so that's 50 squared plus 125 squared plus 175 squared. Square rooted. Lovely. 25 roots. I want it as a decimal really because it's in context. It makes more sense to have it like that. So does it? Doesn't have an accuracy, so whatever's probably fine. And does it say what units? Units are in meters. We don't apply the same rules to things.
No. I apply it.
That all makes sense to everybody. It's like I said, it's difficult to work out from the question what they're actually asking you to do. So a lot of practice on these. Then it says it's only practical to construct a new access way that will be significantly shorter than both of the existing access ways, OP and OQ. We've got the coordinates of P and Q, which are essentially the position vectors OP and OQ. So it's just asking us to find the magnitudes of those and compare them to what we've got. So OP is minus 300, 400, minus 50. And so the length of OP, 300 squared plus 400 squared plus 150 squared, square rooted. gives us 522, which is much bigger. Coordinates OQ, 50. And if we do the magnitude of OQ, 300 squared plus 300 squared plus 50 squared square rooted gives us 427, again much bigger. I need to make a conclusion because it asked me to determine whether they should build a new access lane. So I'm going to say as magnitude of OP and magnitude of OQ are much longer than the new access way, it should be built. Limitations of the model: tunnels might not be exactly straight, the mountainside will not be exactly flat, you can't model it by the equation of the plane. You don't know if you actually can dig this new access way, depending on what obstacles are in the way and stuff. All that kind of stuff would be fine for limitations of the model, and there'll be other things that you can say as well that I haven't said. So tunnel. Are you criticizing my grammar?
Yeah, you should have a semicolon instead of a colon.
Let's do the same thing.
I know you haven't used one since like year 5, but
Wow. We'll take that while you go.
I'm just ignoring him until he goes away.
it's not like it's a north, it's a semicolon, it's not.
So you criticize me and I'm not even wrong. What's this? Maybe obstacles.
You use it instead of